Hello students, in my class 11th lecture today I am going to tell you about the uses of dimensional analysis in the form of numericals. Actually there are three uses of dimensional analysis, in which the first one is checking the correctness of relation, second one is establish the relation, and third one is conversion of a physical quantity from one system to another system. So I will tell you each use with the help of an example. Like, use number first is how we will check the relation is correct or not. For that you should know this particular statement. If the dimension of left hand side physical quantity is equal to the dimension of right hand side physical quantity, then that particular formula, that particular relation is correct. If in case dimension of left hand side physical quantity is not equal to dimension of right hand side physical quantity, then that formula, that relation is not correct. In that sense, I have taken one example here, one formula is here, V is equals to pi by 8 T R power 4 upon eta into L. In this particular formula, whatever the physical quantities are used here, it is written what is its meaning, and in front of that its dimension is also written. In the next step, what we will do? In the left hand side, write the dimension of that physical quantity. In the right hand side, in the same pattern as the formula is given, write the dimension of right hand side physical quantity. Solve this right hand side physical quantity. If right hand side physical quantity is same, dimension of right hand side physical quantity is same as the dimension of left hand side physical quantity, then the formula will be correct according to this statement. When you will see here, both are coming same, that's why LHS is equals to RHS. Due to that, this relation is correct. If in case it was not equal, then relation is wrong. Second, establish the relation. Establish the relation means you know that force is equals to mass into acceleration. Very simple example. If anybody asks you, show that it is, then with the help of dimension you can show. I have taken one example here. The question is derive an expression, means that formula, for time period of a simple pendulum which may depend upon mass m of bob, length L of the pendulum, and acceleration due to gravity small g. In such type of question we always search two things, which is depend, how many physical quantities are depend, and over which these physical quantities depend. So here is time period, and on the time period these three physical quantities are dependent. So write M, L, G in right hand side and D on left hand side. Means the physical quantities which are depends, you write those in right hand side. Now with these physical quantities, put the powers A, B, C. If you like X, Y, Z, whatever you want, you write the powers with each physical quantity. In the second step, remove this sign of proportionality, put equal sign. You know that when you put equal sign, a constant will introduce, put that constant k, and other things are same. It is mentioned here, k is constant. Now in the left hand side as well as in the right hand side, put the dimensions of each physical quantity. In the left hand side, because it is time period, dimension is t, dimension of mass, dimension of length, dimension of acceleration, dimension of constant is 1. Now make a relation like this, in which you collect the powers of common bases, like m power 8, L power b is here, L power c is here, so it is L power b plus c, t power minus 2c. Here no m, no L, but I have written here m power 0, L power 0, and t power 1. Now in both the sides, look the bases, and of equal bases equate the powers, like m, and m is here, so a equals to 0, b plus c equals to 0, minus 2c equals to 1. Solve the value of a, b, c. You will get a equals to 0, b equals to half, c equals to minus half. Put these values in equation first, you will get this result. In this way, you can solve this particular problem if you want to do establishment between the physical quantities. Now, third one is conversion of physical quantity from one system to another system. If you want to convert from MKS to CGS, or from CGS to MKS, then with the help of dimensional analysis, you can do that. How? For that, you should remember this formula. This formula comes from N1 U1 equals to N2 U2. I I told you in my previous lecture. So now n2 equals to n1, m1 upon n2 power a, l1 upon n2 power b, t1 upon t2 power c, where n2 is unknown numerical value of that system in which you are going to change. m1, l1, t1 are the units of mass, length and time respectively in the given system which is given. m2, l2, t2 in which you are going to change units of mass, length and time. n1 is numerical value which is given in a particular system. A, B, C are the powers of unit of mass, unit of length, unit of time respectively in the given system. Okay. Now with the help of a example, I am going to tell you how you will solve if you want to convert a physical quantity from one system to another system. Okay. Now, look in this example. The question is convert 6.67 10 to the power minus 11 Newton meter square kilogram power minus 2 into CGS system. Now you can see in this particular unit, whatever is given here, SI is also given, MKS is also given. So we always try to use MKS. If SI is given, convert that into MKS. So in place of Newton, you can write kilogram meter second power minus 2. On combining whole, you will get in place of this 6.67 10 to the power minus 11 kilogram power minus 1 meter cube second power minus 2. Now you are going to convert this into CGS system. Answer will be same for here, whatever you will get for this. Now n1 is given value. This m1, l1, t1 is given unit of mass, length and time. So kilogram meter second, you can see. A, B, C are the powers of units of mass, unit of length, unit of time, minus 1, 3 and minus 2. Now m2, l2, t2 is unit of mass, length and time in which you are going to change. Means in CGS, so gram, centimeter, second. Put in the formula n1 in place of n1 given value, kg upon gram, m1 upon m2, l1 upon l2, t1 upon t2. Now convert kg into gram, so 1000 gram, meter into centimeter, 100 centimeter, second as it is. Cut this gram, centimeter, centimeter, second, collect the powers. You will get this is value of this particular problem in the system in which you are going to change. Now the question was this. So this equals to in CGS in place of Newton, dyne, in place of meter, centimeter square, in place of kg, gram power minus 2. This numerical value was in this particular given system. So now in this system you have calculated this answer. You can write, you can get the answer. One more thing. Principle of homogeneity. If it is not necessary that always product sign or division sign is given in the relation of physical quantity. Might be it is in the form of equation, means plus sign or minus sign is present, then what you will do? So if any relation is given in the form of equation like this, y equals to x plus z plus p upon q, it may be minus, so don't think that it is only for the positive side, it can be negative also, where y, x, z, p and q are the physical quantities. Maybe it is force, it is velocity, it is momentum, it is power, it is work, anything. Then if any equation is given in this form, any formula is given in this type of equation, then whatever the physical quantity is written in the left hand side, that is y, is separately equal to the dimension of right hand side physical quantity. Means separately, this is and this, you can separate in two parts. So dimension of y equals to dimension of x, and dimension of y also equals to dimension of this whole. Now in this relation, z plus p is written and both are physical quantities, so same physical quantities can be added. That is why dimension of z must be equal to dimension of p. If it is minus sign, then same physical quantities can be subtracted. Like you cannot subtract kilogram from the meter. You can subtract kilogram and kilogram. You can add kilogram and kilogram. That is why I have written this way. So these are the numericals based on dimensional analysis. Okay, all the best.